Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Your host is Tobias Macy, and today I'm interviewing Samuel Colvin about the Pydantic AI framework for building structured AI agents. So, Samuel, can you start by introducing yourself?
Yeah, hi, thanks so much for having me. I'm Samuel. I'm originally the creator of the Pydantic validation library. Now I run Pydantic Inc., the company, and I was the original developer of Pydantic AI, the agent framework, although there's actually a team now who maintain it along with me, so I'm not as active as I was.
And do you remember how you first got started working in the ML and AI space?
So it's actually Pydantic AI is relatively recent. It only came out end of last year, and it came about through we started to add AI functionality into Pydantic Logfire, our observability platform, and I was very proud that all of the other agent frameworks were using Pydantic for validation, but I wasn't particularly impressed by their engineering quality within them. And so when I started trying to build with them, obviously the underlying SDKs are generally pretty good, but they're bare bones as you would expect. Tried to use the agent frameworks out there and wasn't very impressed. And so guess we thought we could do better. Started off as most things as an experiment to see whether it was possible. And then that kind of worked. And here we are.
And so you gave a little bit of an overview about kind of how it got started and why. So I'm wondering if you can just give a bit of an overview about sort of the scope of Pydantic AI and what your overall goals are for it.
We as a team come from reasonably experienced Python engineers moving into AI. We're definitely more Python experts or engineers than we are AI experts. And so I suppose those are the people we're trying to appeal to. We're trying to build an agent framework that has roughly the same engineering quality, maybe hopefully a bit better. Some people might say a bit worse, but in the same order of magnitude as other prominent Python libraries, rather than the other agent frameworks where the quality is generally much lower than that in my experience, and has to have the same taste. So try to be type safe, try to have proper unit test coverage, try to not have excessive levels of abstraction, try and do the things that you obviously don't want to have to re-implement every time you build something, but let you go and build the app you want rather than come along with our opinions about how you might build something. In terms of scope, I think we're like Pydantic AI just went V1. I suppose along with the caring about quality, we want to care about not breaking your code. And so we will from now on try hard to avoid excessive breaking changes. But there are some things to add. Like we don't have a support for embeddings yet, which is a weird omission, but we just haven't got around to building it. We wanted to do it right. I think along with that, there are some open questions about to what extent we want to have opinions about how you might do RAG and vector search, or whether we just leave it completely up to you. I think we are yet to decide exactly how we're going to do all those things. But I suppose for the most part, the primary thing we offer is the general agent interface that most of these frameworks have now centered around. So we have that agent type. I think there was probably a point end of last year, maybe even beginning of this, where people claimed or thought that one of those agents was what you would need to build your agent application. So there are two things that people mean when they say agent. They mean effectively a microservice that goes off and does a particular task. And then they mean a very specific iteration loop with a particular LLM to solve a particular problem. I think there was a point at the beginning of the year where people thought you would have one code agent inside a microservice agent. I think now lots and lots of applications will have multiple, maybe even many of those agents to solve one particular task. But that agentic loop is still very useful. It's just a building block rather than the top level construct.
You mentioned that, of course, there are a number of other agent frameworks in the ecosystem. The overall landscape of those frameworks has been in rapid evolution since the introduction of the first handful of them. I think LangChain and Llama Index were maybe the first two that gained any sort of prominence, but it seems as though every week somebody introduces a new flavor or a new variation of an agent framework with various levels of scope and capabilities. And I'm wondering if you can give your summary of how you view the current state of the ecosystem and maybe some of the broad categories that you see those different frameworks falling into.
So there's two agent frameworks from the model providers. So OpenAI agents and Google ADK are both released earlier this year, generally reasonably well regarded in terms of the level of abstraction that they provide. I think they're a step up on what, putting Pydantic AI to one side for a minute, what came before. They're still nowhere near as type safe or as, I think, production ready as Pydantic AI. I think maybe even some of the people inside those organizations would agree on that. I don't know. And then there are all of the other agent frameworks that have been around for longer than we have. I think there's only three that have really come to any prominence this year are us, Google, and OpenAI, and we're way ahead in terms of downloads on those guys, I think, for fairly obvious reasons. Probably the biggest differentiator is this modern definition of an agent. I say modern, as in this year, maybe very end of last year, that we, Google ADK, Arno, OpenAI agents all agree around. And then there is LangChain in particular, who have chosen to disagree with that model of agent. And they have LangChain itself, the low-level library for unifying requests. And then they have a LangGraph, which is their attempt at building this graph library for building more complex application. And so I think, yes, there's people like CrewAI and Llama Index, but I think the choices now come down to the three choices of LangGraph, the frameworks from the model providers, and us. And I would say that it was getting towards being a no-brainer to use us, but I think, and we would expect to overtake LangGraph in terms of downloads later this year. I think graphs are, we have graph support in Pydantic AI. We also have the low-level support. Our graphs are type safe. They don't allow parallel node execution because doing that is almost impossible in a type safe way. We think durable execution with something like temporal is a much better solution than parallel node execution in the graph, unless you can do it right. I mean, it comes down to whether or not you think you need to build a graph. And people have been saying they need to build a graph for a long time, and very little of the code in the world is actually a graph. Graphs are great when you want to re-enter a graph in a particular point, but durable execution arguably solves that instead. I mean, but then again, lots of people think graphs are great and they use Pydantic graph and do it that way.
And another aspect of the current situation around the agentic SDKs is the overall patterns of how to actually build those agentic applications, where you mentioned that at one point it was thought that, oh, all you need is one agent object and that's going to do everything. And now it's, oh, well, actually, you need maybe an orchestrator agent with lots of sub-agents. Those sub-agents need tools, etc. And I'm curious if you can talk to some of the ways that you're seeing the evolution and maybe even starting to see some level of consolidation as far as the patterns and integrations that Pydantic AI needs to support, and just some of the ways that people are actually building with it to be able to orchestrate and iterate on these agentic patterns.
Yeah, I think there were a lot of people, particularly early on in the development of this stuff, who assumed that we needed completely new paradigms for AI. And I think they often assumed that in part because they just didn't know about the existing paradigms. They assumed we needed something new because learning how engineers have done things until now seemed like a lot of work. And so saying we need a new way of doing it was a nice shortcut. I think that there has been consolidation around the idea that existing engineering best practices actually solve most of these problems. Like, we have the concept of orchestration. It's one function that calls other functions. And in some sense, agents are no different. You can call an agent inside a tool, obviously, particularly if you have type-safe dependencies, which we do. You can call that an orchestrator agent if you want. I mean, what was the one a few weeks ago? There was deep agents, which was basically one agent that calls other agents. I mean, that's like, get the agent to return structured data of a list of tasks and then run an agent for each of those tasks, sometimes in parallel, sometimes not. These are just like, the primitives all exist, and now there's just a lot of fluff about what we're going to call these high-level concepts. I suspect most of them will go away, And it will come down to like, there will be herd knowledge about how to go and build these things.
And in terms of the process of going from I have an idea to I actually have an agent developed, there's also the aspect of one, determining is this even the right use case for an agent, or would I be better off just writing some sort of script, or maybe using some robotic process automation framework versus an actual LLM driven loop. And I'm curious if you can just talk to some of the ways that you're seeing people go through that discovery and design process of I have a problem, I think this is the right hammer for this nail, and then actually iterating on that to prove it out and get it into production.
Partly related answer to this question, partly an answer to your previous question. The added complexity to this is that there is a lot of there's a lot of blur in whether or not it works. It's not like building something with a protocol or something deterministic where you can be like, yeah, I can do this with HTTP. No, I can't do this with HTTP. With LLMs, it's much more blurred. Is this possible? Is this not? Does it involve a bit of prompt tweaking? Is it fundamentally impossible? And that ambiguity allows for an enormous blurred space of people coming up with grand names for things that are actually relatively simple concepts. In terms of working out whether or not you need an AI for it or whether you need an agent, right? So one useful data point, we have low-level methods. We call them the direct interface to the LLM. So all that we're doing in that case is we're giving you a level of abstraction over all of the different models. So you can change model with just one line of code, and we add observability if you want it, but like we're not doing anything else. We're not doing anything agentic on top of it. As far as I know, very few people use that direct interface. And that is because you almost always want some of the functionality from an agent. I mean, people talk a lot about this agentic loop, but anything as simple as I want to get out structured data, and if it's not right and I get a validation error, I want to pass that back to the model and get it to try again, which you almost always want, you may as well have an agent. And there is the overhead in terms of engineering work, or the overhead in terms of cost or latency of using an agent where you are fundamentally making one LLM call is trivial to zero. So why not use an agent in those situations? And if I turn out I need the agentic bit, great. If not, I don't. I think people find it very useful to be able to look at the actual request made to the LLM. We support that, so you can literally see the JSON sent in Logfire. That helps people a lot sort of understand what the framework is doing. In terms of working out where AI works and where it doesn't, I have quite a lot of opinions on that. I might be giving a talk on that in a couple of months, but I think that there's a lot of information about a bunch of tried and tested methods that definitely work, or applications that definitely work for AI. There's much less information out there about what doesn't work, because predictably people don't talk about their failures as much as they talk about their successes. So there's lots of evidence on this worked really well for us, very little evidence on we tried this, we spent 6 months banging our head against a wall, and then we failed. So there are a few very public failures of, for example, Klarna said they were going to replace all of their support with AI and then had to back off and rehire their support people. But there are not that many of those examples, because understandably companies don't want to talk about them publicly that much.
Digging into the Pydantic AI framework itself, I'm curious if you can talk to some of the design and architecture of the project and some of the ways that the scope and focus of it have evolved from when you first started building it.
I mean, it's got bigger than I kind of expected, because it has got bigger in terms of its adoption than I had kind of hoped for, even when I started. But it's still the same fundamental thing. We have the agent type. MCP has obviously come along and given us this lovely protocol to make, in particular, tool calls generically, and so we have great support for that. We obviously have extended it to do stuff like observability well. I think the fundamental differentiator, we think, is type safety. I think type safety is incredibly important and only getting more important. And that is in no small part because coding agents are writing more and more of our code. And coding agents absolutely love type safety because they get to basically check their homework as soon as they finished in a side effect free, very fast way. And so if you're an experienced developer and you're going to write all your code, you're going to want type safety. If you're not an experienced developer and you're going to use Claude Code or your coding agent of choice, you need type safety even more. And so I think that, look in the TypeScript world. No one is writing JavaScript unless in a very edge cases, right? Everyone is using TypeScript. It's a no-brainer now. And I think Python's type system is not as advanced as TypeScript. We're getting to a kind of comparable level of feeling of I can see there's no squiggles in my code. It's going to run and I'm going to get something interesting, even if it's not perfect. The squiggles in my code, I probably need to fix those squiggles before there's any point in trying to run it. The same feeling you get in TypeScript. That doesn't exist in other agent frameworks because they decided to go and invent their own exotic use of the language that doesn't support type safety. And I suppose our experience having built Pydantic and learnt the hard way when to do things differently and when to just stick to what's known means we've tried to do that right. Beyond that, I think a lot of it comes down to a much less clear-cut basic engineering judgment or engineering taste of what level of abstraction to give, when to add new functionality, when not to. If you look at some of our other agent frameworks, they have hundreds of integrations with different databases, which, as far as I know, are not really maintained. And so when people use them, they get broken the whole time. We won't do that. Someone came along and submitted a PR the other day to add SQL-like supports to our graph snapshotting. And I closed the PR and refused to accept it because the complexity overhead of starting to manage schema within open source when you're fundamentally managing schema in other people's projects is very high. And we don't want to do that until we're very sure it's the right idea and we're very deliberate about doing it right. I think in other frameworks, they'd be like, great, someone's added SQL-like support. That's a tweet. Let's go merge it.
Digging into the type safety aspect and in particular the structured inputs and outputs when dealing with these large language models, I know that especially a year or so ago, getting one of even the frontier models to reliably output any sort of structured data was like pulling teeth. And you mentioned how, because of the fact that you have that type validation built into the framework, it provides that fast feedback to the LLM. And I'm wondering if you can just talk to some of the ways that you've engineered that aspect in particular for being able to do that validation, and maybe some of the ways that the framework itself is incorporated into the context management for the LLM calls to be able to encourage those models to generate the appropriate structured responses.
Yeah, I mean, I think for the most part, the models are pretty good at this. The models understand JSON schema. And so we don't do anything particularly clever in terms of how we prompt them by default. We use tool calling. So we basically register a tool. If you do a standard agent with structured output, we register a tool called final output, or final result, I think. And it obviously has a JSON schema of whatever data type you've given it. And that is then how the model returns structured data to you. If that fails, we return effectively JSON of the Pydantic validation error to the model. And I think we're probably quite lucky in that the models will have been trained on Pydantic validation errors. And so they're pretty good at understanding them. And I've been shocked about how good they are at either getting it right in one shot or learning a bit from one error and returning it right. Like sometimes I'll get the schema completely wrong and they'll misunderstand the structure and one validation error and bang, they go and get it right. I've been amazed by how effective they are. Two things I would say. One, we also have support for the built-in structured output mechanisms that are available in Gemini and OpenAI. If other models add it, we'll add that built-in support. And we also support structured data output via what we call prompted. So we basically give the model in the system prompt the JSON schema and we say, please return JSON that matches the schema. And that can work well on the smaller models that can't do tool calling. I don't know. I think I spend most of my time working with frontier models. I'm not so interested in making the Olama experience great because that's not where most of our customers are especially interested. We also have, I don't know if it's added yet, but we've been working with .text to add support for outlines. So when you do have a local model where you can prompt it by controlling the mask of different tokens it can respond with, we should have support for that, if it's not done yet, fairly soon.
Another interesting aspect of the ways that I've seen the agent space evolve is that there has been the frontier models in particular that have heavily invested in allowing the models themselves to understand tool calling. And then there's also, I think it's the small agents framework from Hugging Face that is focused instead on, rather than using natural language inputs and outputs, they actually will set up the model to do code generation for the tool calling and execution instead. And I'm wondering if you could talk to some of the ways that you're seeing the overall space incorporate some of those ideas beyond just the everything is natural language to maybe some things are code, or I know there's also some research into the large action models, etc.
Yeah, so I've been a big fan of Hugging Face as a company for years. I'm amazed that they're prepared to release something, small agents, the way it has, because it's basically running untrusted Python code on your machine. And they do a bunch of stuff to try, as far as I understand it, to kind of mock out obviously dangerous functions. But the history of sandboxing in Python is a history of people failing to sandbox Python in any sensible way. And so I'm sort of amazed that they're prepared to put their name next to something so obviously dangerous. On the code generation side, we have MCP run Python, which is our equivalent, basically a way of running sandbox code. Instead of attempting to mock the language and wait until we get a remote code execution vulnerability reported, we use Pydantic to run the Python code, and then we sandbox that within Dino. So we have basically V8 level of isolation between the operating system and the code that you're running, and we think that is a safer way of doing it. Although even that has its edge cases, because although you can kill the process if it goes on for too long and you can't escape the sandbox, you can still use up a lot of memory, and you could your process. So I think remote code execution is a very dangerous thing. It works incredibly well in the simple case of use Python to calculate how many days between these two dates, or use Python to calculate how fast someone was going if they got from Ohio to Cincinnati in 7 hours. But if you actually want to go and use it in a production situation, this let the AI write whatever code I like, in turn prompted by a user, I think is terrifying. I think tool calling works extremely well for the vast majority of structured outputs, and so I think that's the default way of doing it. I think I think Claude Code in particular, but others have probably demonstrated that there are better ways of doing complex workflows than writing code. So Claude Code obviously basically writes Markdown in the form of bullet points of what it's going to do, and then it goes off and executes those tasks. You can build that very easily with Pydantic AI. You basically have one agent where you say, analyze the user's input and return bullet points with each task that we should perform after that. Then you have a second agent, where the system instructions are, read the following Markdown and turn this into structured data with particular steps for each of the tasks in bullet points. And now we have structured data of each task we need to go and run. And then we go and use whatever construct we need in Python to go and run all those tasks. It could be distributed over many nodes. It could be using it could be using async IO, multiprocessing, whatever you want. And then at the end, you combine those results again, and you have a final agent that generates the final user output. Now we have deep agents implemented in Pydantic AI, but we don't need any new special concepts or libraries. We just need to think for a bit and use standard engineering practice.
The other aspect of constant change that we've already touched on a little bit is the model capabilities and the set of models, the providers of models. I know that Pydantic AI has built-in support for a number of the different model providers. I know that other frameworks have leaned on some things like Light LLM as a means of proxying to those different endpoints. And I'm wondering if you can just talk to some of your thoughts on how you thought through how to manage the constant churn of model providers, available models, et cetera, in a way that reduces the cognitive overhead for the users of the framework while also not papering over the important differences between them.
Yeah, so a lot of people, including, I assume, Light LLM, although I haven't spoken to them, so I'm guessing at this, have had a lot of problems with this year, because what everyone did, OpenRouter, Light LLM, others, was they basically converted all requests from and to the OpenAI chat completions schema. And that worked very well, because now we had a universal schema for whatever model you wanted to go and talk to, and most things can do OpenAI, and so you could connect anything, spoke that. And then I presume in no small part because of that, OpenAI went and released their new Responses API, which is their new shiny API where they're adding more features in general. And so all of those proxies now are a problem. Are they going to stick to the old protocol that doesn't have things like built-in tool calling or chain of thought? Or are they going to invent their own new schema, which nothing supports? Or are they going to upgrade to OpenAI responses? If you do that, not everything is supported in OpenAI responses. So, for example, audio isn't supported by it. But also, you're now just moving to another OpenAI schema where they could do the same rug pull down the line. And so I didn't know that was going to happen when we created Pydantic AI, but I think we were very lucky that we didn't center around someone else's schema. Internally, Pydantic AI has its own model for recording messages and exchange between multiple steps, calls to a model. And we use that as our unification layer. You can access that if you use the direct interface, but for the most part, you can ignore it completely. But that means we can add new types, chain of thought, whatever else we might want, without having to rely on some third party to go and add to their schema. I also haven't found there wasn't a good unification layer that actually seemed to have the code quality that we were looking for, which is why one of the reasons we started off building our own. But I think in the long term, that turned out to be a good decision.
One of the overall goals of creating a framework in the first place is that it provides a smoother experience for people who are trying to operate within a given space, where you have web frameworks such as Django, FastAPI, etc., that are very focused on accelerating the path to delivery for a particular style of web application. You have frameworks for working with data engineering workflows. In an agentic AI framework, obviously the goal is to create an agent, which is, as we've discussed, a very broad space at the moment. And I'm wondering if you can talk to the ways that you think of, both at the macro and at the detail level, that Pydantic AI is engineered to guide and encourage best practices and some of the, in particular, nuanced details of the framework that maybe are not as directly obvious when somebody first adopts it, but that helps them as they get to that day 2 and 3 maintenance and ongoing support of an agentic application.
Yeah, I mean, I think I built this because I wanted to have the same feeling I have from using FastAPI, but with LLMs. I wanted the FastAPI of LLMs. Obviously, as supported Sebastian in maintaining FastAPI, because Pydantic is obviously one of the main building blocks of FastAPI. Starlet, the other primary building block, is maintained by Marcelo, who works with me and works on Pydantic AI. So we, between us, had done, and actually David as well, had spent a long time working with Sebastian to support FastAPI. So although we hadn't maintained a web framework, I think we knew about as much about that process as anyone who hadn't themselves maintained a framework. And I just wanted that same feeling of type safety but simplicity to be possible. And I think we've done a pretty good job of building the FastAPI of LLMs, if I say so myself. In terms of long term, yeah, I have this theory that to build really successful open source, it needs to be understandable in 30 seconds, usable in 3 minutes, and not drive you around the bend after 300 hours. And I think I've done that with Pydantic. I mean, Pydantic is obviously, through its widespread adoption, clearly ticks all three of those boxes. I think Pydantic AI is doing a pretty good job of those three things as well. I mean, I guess there'll be a few people who are at 300 hours of using it, but there are definitely a lot of people using it in production who seem to be having a good experience. We obviously broke a lot of stuff pre-V1, and that frustrated people occasionally. We worked hard to do deprecation warnings that told them how to upgrade or how Claude to upgrade. But I think it comes back to like general engineering taste, as in don't give excessive levels of abstraction. If you have these like very specific ideas of how long-term memory and short-term memory should work, then you have to maintain an awful lot of code to maintain these like very complex abstractions, but two, you're at risk of being left behind when people's ideas of how memory work change a bit. Whereas if you build the right primitives and are like, we have tool calling, you can go and implement memory in one of these ways, you're not so much at risk of being replaced when the taste in how you build stuff with AI changes.
That brings up another interesting aspect of framework development is you've already alluded to the ongoing cost of accepting feature requests where they are free as in puppy. And also, as you've said, some of these frameworks have explicit integrations with certain subsystems or ancillary services, which helps with the initial adoption and helps people get up to speed quickly. But also by choosing not to have those capabilities integrated into Pydantic AI, it leaves that as an exercise to the developer. And I'm wondering if you can talk to some of the ways that you've thought about maybe smoothing that transition process of providing some of these sort of escape hatches or stub instances to be able to say, if you want to be able to call out to a memory system or a vector store, here is the sort of abstract interface, and then maybe here are some examples or some resources that you can use to pull in as extensions to the framework to give some of that out-of-the-box experience and a similar overall feel to interacting with those resources.
I would say 3 points. First of all, again, I try and copy FastAPI because it's been so successful. FastAPI has never had a default database, right? Sure, Sebastian built SQL model, but there is not like you get SQL model built into FastAPI. It's there as an option. You can go and build it however you like. And while we build a lot of stuff on FastAPI, we don't use SQL model. And it would be annoying if we had to try and escape hatch SQL model to do our own stuff inside the web framework. So that's, whilst Django is amazing, I started my career on Django. I love it. Now I would be frustrated that it was hard or impossible in places to go and escape into writing raw SQL, because I would prefer to write SQL than use an ORM. And so I don't think you need to go and have database support in a framework necessarily. So we have examples in Pydantic AI. I think one of the things we've done heavily is lean on examples. We have an extensive example section where we can go and have slightly more esoteric demonstrations of what we can do without like supporting that in the library and therefore guaranteeing it will be around long term. We've also been unwilling to go. I mean, we've had umpteen 10, 20 different people coming along and saying basically, please can you accept our PR to add documentation on how to use Pydantic AI with whatever it is we build commercially. So whether it is a observability platform or a security store or a database, and I have reasonably bluntly refused most of them. And that is because the engineering quality and even in the example wasn't there. Like they all just went and turned off type checking at the top of the example because they couldn't be bothered to work out how to get types to pass. And I'm like, no, at that point, I'm not going to accept a pull request if you just switch off all of our tests. Is that because you think our tests are unnecessary or because you think you're special? But also, I don't want to go and have a like explicit agent security orchestration provider who we go and support, because if they go and change how they do things, we're then tied into it. I mean, I think if you add something to a library as high profile as Pydantic AI and you make it V1, you're kind of guaranteeing that in big enterprises, you're going to support most of those principles for years. I mean, maybe we'll release V2 6 months or in a year's time, but we'll then go on and support Pydantic AI V1 for a sustained period of time, right? And so I'm very careful about what we go and add. And I think one of our golden rules is like, would we use it? And for example, that like SQLite backing for Pydantic graphs, I was like, would I really want to go and use that? Probably not in production. And if it's not in production, I don't need database support. So like the rule of thumb is, would we use it? Not like, are we going to use it immediately? But is that of a code quality? Is that of a approach that we would use? And if I'm never going to use it, then it's probably not going to be as well maintained as something that I care about and use every day.
Another approach, pointing to what you referenced with the SQL model project, is to have the core framework. I know that you're very familiar with this, given your work of Pydantic going from V1 to V2, where you've separated out the core from the other interface. And so I'm curious if you've put any thought into having some of the extension projects where you have Pydantic AI core, and then maybe you have Pydantic AI memory, Pydantic AI vector, etc.
So we do that a bit already, and actually UV support for workspaces and multi-project repos is great for that. So we already have, we do something quite novel in Pydantic AI. So we have Pydantic AI Slim, which has absolutely minimal dependencies, basically Pydantic and HTTPX. Maybe not even HTTPX, actually. But in particular, none of the SDKs from the model providers are installed by default. And then we have Pydantic AI, which is just a wrapper package, which installs Pydantic AI Slim and loads of packages that you might want to use with it. Maybe too many now. We might actually want to strip it back a little bit. But that allows you to install. So if you specifically want to use Pydantic AI with OpenAI and have minimal other dependencies, you do Pydantic AI Slim, optional group OpenAI, and now you have just the packages, just the libraries you need. Pydantic Graph is a separate package, although actually Pydantic Graph is used under the hood by our agent type. So it's a required dependency, but we have Pydantic Evals, which is a separate package, which is an optionally can be installed. We even release our examples as Pydantic AI examples. So you could even install them if you wanted to go and get the code. And I think there'll be some other projects that we will do similar things with. So for example, actually MCP Run Python, although it is implemented in Dino, it has a Python wrapper. That is a separate package that you can go and install if you want. So we will do exactly that. If we decide to go and do more memory stuff, that would be a separate package that you could opt into if you wanted. But we have the option to install it by default in the Pydantic AI meta package if we so wish.
You've mentioned also that you have the Pydantic Logfire project and service, and agents, as we've discussed, are a novel and new way of building software. And I'm curious if you can talk to some of the new and exciting failure modes that they introduce and how people should be thinking about monitoring and observing and maintaining the overall uptime and reliability of these systems.
Yeah, I mean, obviously we have great integration between Pydantic AI and Logfire. I will just call out that unlike some of our competitors, instead of trying to build on proprietary protocols and lock people in, we try and encourage people to stay with us by building great software. And so everything we do is over open standards. So the data that Pydantic AI emits is OpenTelemetry following semantic conventions, and Logfire can basically read that data and give you a lovely view of what's going on within your agent run. I think the first thing to say is not so much about dealing with errors explicitly, but rather at development time. Like an experienced engineer can basically implement from scratch let's say, a FastAPI endpoint to go and get some data from a database. And if they can check if the column that they're querying on has an index, they can eyeball it and be like, that query is going to be sub 100 milliseconds to call that endpoint at basically any scale. And they can go away and they can get that, basically implement that from scratch. That just does not exist in AI. Even the most experienced people need to go and have a play and try different things and experiment. And so that comes back to my type safety point. Type safety is great because it lets you refactor quickly. But also at development time, you want that view of exactly what your agent is doing just to understand what the heck it's trying to do and work out how to make it perform better. Then once you're in production, LLMs are slow, expensive, and unreliable. The three things where you really need observability to understand how they're behaving. And the other added complexity of them is that you can't strip out the user parameters and look at the behavior in isolation. So with a SQL query, you can strip out the parameters or not send the parameters to the observability platform. You can go and look at the SQL and work out what went wrong, especially if you have a schema and you know where the indexes are or whatever else. That's just not possible with LLMs. You have to know all of the content to understand what the LLM has done. So the sensitivity of the data that you end up sending to your observability platform is that much higher. And that's one of the reasons we offer self-hosting for Logfire and why lots of big enterprises self-host it rather than using the cloud version, because they're just often legally, regulatorily required to have that data inside their own VPC. In terms of other problems, I mean, I think there's an enormous open space of security questions that often are not don't have good solutions yet. I think we're still working out how to do security. I think the world is waiting for the first really big security vulnerability of an LLM application, and then people will start to take it more seriously. I think there are a bunch of things we've avoided doing because we know they might be insecure, but I don't think we have any, beyond that, we don't have any particular special sauce on how to build things securely other than follow best practices and try not to have too much surface area of our application so we can keep what we do safe at least.
And in your experience of building Pydantic, obviously you gained a lot of context and understanding of how to run a large and successful open source project, and Pydantic AI is following that same trajectory. I'm wondering if you can just talk to some of the key lessons that you gained from your work on Pydantic to then leverage it into Pydantic AI to help sort of smooth that process, and maybe some of the early mistakes that you learned that you were able to avoid in the development and promotion of Pydantic AI.
Yeah, I think so. So when people talk about open source, people love this idea of it's this collaborative, everyone comes along, scratches their own itch, solves their own problem, and basically once I build a good open source project, it can kind of run itself. That just does not exist. I mean, I guess Linux, which is the single most successful open source project ever, does have genuine collaboration from lots of different people, but still Linus sits there and merges every PR and shouts at people when they do things wrong. I mean, it does not manage itself. Python, again, another very successful project, so big that it does actually have collaboration from different organizations, but still takes enormous amount of management. At the Pydantic or Pydantic AI scale, which is, I guess, a step down from there, I have not been successful in ever building this utopia of where lots of different people contribute even amounts. And I don't see many other projects where that actually happens. I mean, go and find me the top 100 Python package where you literally have 10 different people from different organizations collaborating equally. It doesn't exist. It ends up, like all things, with one person who really, or two or three people at most who really care, who end up driving these things forward. And one of the big differences with Pydantic, so one thing we learned from Pydantic was we didn't try and go and say we're going to be all about collaboration and all about contribution. We optimized for the end library being good rather than for having as many people as possible contribute. Obviously, the other big difference is we're now a company. We have the resources to have a team working on it full time, whereas with Pydantic, it was in my spare time. I think the same principle exists. It's just one or two or three people who drive it forward, who own it. Obviously, the big mistake we made in Pydantic was we released V1 with a bunch of broken APIs that we should have gone and fixed before we released V1. And in places, I kind of was over my skis in terms of adding more functionality than we needed. Nothing as badly as other people have got that wrong historically. I mean, what Django used to have support for validating French telephone numbers. I mean, and other libraries have made many bigger mistakes than that. But I think that's why we're so cautious about when and where we add more surface area to Pydantic AI, having got that a little bit wrong in Pydantic in places.
And in your experience of building this framework, putting it out into the public, building a company around it now, and working with people who are developing their own systems on top of that framework, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
It's funny. I don't get that much contact with how people actually use it in the code level of what they do, which is kind of frustrating. I wish I got more, was able to see more of exactly how people use it. I sat next to someone at a dinner who was using Pydantic AI to scrape or to process the data they scraped from forums to give to law firms who were looking for new class action lawsuits. So they were basically scraping the internet to try and find any whiff of a class action lawsuit, which I thought was a particularly weird and novel one. A lot of use in financial institutions, as you could imagine. A lot of use in big medical companies, perhaps a bit less obvious, but I guess you can kind of understand that as well. But in terms of the actual novelty of the application code, I don't see a lot of it because a lot of that stuff is closed source.
And another aspect of being a framework developer that just struck me is in the early to mid 2000s up until around 2010, there was the framework wars of the sort of Django versus Ruby on Rails versus Flask versus Sinatra, et cetera, where everybody was trying to promote their way as the best option. And there was a lot of tribalism that developed as a result. There are a number of different AI frameworks, although I don't think there is as much cohesion as there was in the web framework days. And I'm just wondering if you're seeing any similar sentiments of people who are developing that sort of tribal identity around their AI frameworks.
I think there's a reasonable amount of it going on and what people like. And I think there's a bit of what does that mean about who you are, right? As in, if you were to draw a cliche, it would be that AI SDK is pretty well seated as the preeminent one in the JavaScript world. So if you're a JavaScript developer, you're probably an AI SDK fan. In Python, I think it's pretty split between LangGraph and Pydantic AI, but then there is a whole cohort of other libraries out there as well and who knows where we'll be in 5 years' time. I assume that we'll have had a bunch of concentration around a small number of libraries that most people use. Who knows where we'll be.
I think that's another interesting point too, is that maybe some of the more, at least the ones that I'm most aware of in terms of the AI frameworks, have been very biased towards Python, because Python has become one of the major languages for working with ML and AI systems. But to your point of the AI SDK, JavaScript has also gained a lot of ground, largely because of the fact that most of the interaction with these models is done over an API, which is the whole reason for being for JavaScript, at least in its original form. And I'm wondering if you can talk to maybe some of the ways that you're seeing the API orientation of these models influence the language selection or the proliferation of frameworks across languages as a result.
I'm sure I will offend someone by saying this, but hopefully they're not listening to your podcast. But my instinct is it's basically Python versus JavaScript. I suspect that in terms of download numbers, those two are way ahead of anything else. I kind of think, why would you write any language other than Python, TypeScript, and Rust? I know that's also going to offend people, and given that Rust is not a good choice of language to go and build an agent framework in, I think it's between Python and TypeScript. They both have their advantages. I agree that those are the two options. I think the other interesting thing that I don't love, although I'm obviously part of the problem, all of these libraries are maintained by startups who are this is not, as something we also do, we also maintain some open source. Like to Vercel, AI SDK is an important part of what they do. To us and LangChain, our agent frameworks are existential to our reputation. And so it is a different world, and I'm sure that we will meet a different failure mode to the failure mode of Django was not a startup, Flask was not a startup, FastAPI, it now is a startup, but was not for a long time. So I think we need to be quite careful about which startups we trust with using their open source. Look, and I'm saying that because I think we're as trustworthy as anyone out there. We've maintained Pydantic now for since 2017, 8 years. I think Pydantic will be around a lot longer than that, and I think Pydantic AI will too. And we have shown our taste in following best practices and building on open standards rather than trying to lock people in. I mean, I know which one I would want to risk my company on, even if you ignore engineering quality, but that's my taste. I mean, I think Vercel also do a great job of, I don't agree with everything they do, but they've done a great job of building Next.js and building real open source and gently encouraging you to host it on their platform, but not forcing you to. I have respect for them in that regard.
And in your experience of building the Pydantic AI framework in particular, what are some of the most interesting or unexpected or challenging lessons that you learned personally?
I think we have pushed the boundaries of what you can do in type safety or typing with Python. Hopefully that doesn't, for the most part, doesn't come over to the user. That's for us internally. I mean, I was showing a team at Anthropic the other day that concatenate type in Python's typing system, and none of them had seen it before. And I think we use that in the numerous places. I think once you get to type alias type and doing stuff like that, like we push the boundaries of what you can do with Python's type safety system. I think evals are as yet an unsolved problem. I think we have some interesting stuff there. We have a reasonable evals library, but I think we're still as a industry, as a community, still yet to work out the best way of doing evals. So I think that is a unsolved problem as of yet.
And so, for people who have decided that they want to build an AI agent, whether just for a hobby project or for production use case, what are the situations where you advise against using Pydantic AI?
I mean, if you're going to run stuff in the browser, I wouldn't go and try and do any. I mean, you can run Pydantic AI inside Pydantic, but I wouldn't recommend doing that. I think beyond that, it's a great choice. I mean, look, if you're more comfortable in TypeScript, you're probably not going to pick up Pydantic AI. If you're really determined you want to go and experiment with doing something in Rust, that's fun to do. Great. An awful lot of people are like, oh, don't use an agent framework. Oh, these are mistakes. I think those people have very short memories or little imagination. Like zoom back to, let's say, 2002, in the early days of the web. I'm sure you would have found people building web applications and being like, I don't need one of these web frameworks. I'm going to parse all the HTTP headers myself in C++, and that's going to save me numerous clock cycles by not having to put into memory the headers I don't need to access. Why would I use one of these nasty web frameworks? I think the same basically applies with AI. Like the levels of abstraction only grow. You don't want to go and re-implement the stuff we've done from scratch. Of course, go and experiment by doing it directly. Use the APIs. Learn what an LLM can do. If you want to get on and build an application, you really don't want to be faffing around using the SDKs or indeed the raw API directly. And if you want to go and build a web framework from scratch because you think it's really interesting to understand HTTP2 or the most effective way to build a multi-dict, that is an interesting thing to do as an academic project. But that is a very different thing from what we're building for, which is to put things into production.
And so, as you continue to build and iterate on the Pydantic AI framework, what are some of the plans that you have for the near to medium term, or any particular projects or problem areas you're excited to explore?
So Vercel released Vercel AI Elements very recently, which is basically an amazing toolkit of React components for building UIs. They have their own protocol where they basically for streaming messages to and from the server. And we are about to add support for that to Pydantic AI. So you can go and build a front end with React with those elements very easily. Or we may even give you a pre-built UI for doing some of that just as a kind of demo and for quick iteration. Embeddings are a really important thing that's a no-brainer that we need to go and add fairly soon. So we'll be doing that. I think there is some more work to carry on improving the documentation. I think we have durable execution support with both temporal and deboss. I think we would love that to extend that more into Pydantic graph so you can build durable graph execution. Yeah, that's a few of the top level things where we want to get to soon.
And are there any overall industry and ecosystem trends or predictions that you're paying particular attention to or have interesting predictions for?
As I've said already on this podcast, I think type safety is only going to get more important as agents write more of our code. So I think that is very important. I think MCP is enormously hyped, but is really influential. We haven't talked about it lots on here, but I think MCP is really, really valuable. We have, I think, the best support for it in Pydantic AI, and I think we're going to continue to. I'm a somewhat absent co-maintainer of the Python MCP library. Marcelo on my team is a bit more active. I think I'm like bullish about what MCP can do in the medium and long term. Yeah, I think that we're going to standards and best practice are going to evolve, and that those who are building in silos, isolating themselves from the rest of the ecosystem, at some point are going to come a cropper. But so far, that seems to have worked quite well.
Are there any other aspects of the Pydantic AI framework or the overall space of agentic applications and developing for them that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think we've gone over all the main things that come to mind.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling, technology, or human training that's available for AI systems today.
I think that no one has a clue about how to do security. I was talking to a security company yesterday who was saying, the current answer from the model providers themselves is let us take care of it. Don't worry, darling, we'll do it. And I think that's probably what, in a very similar way to Microsoft at one point said, don't worry about security, just use everything Microsoft and we'll take care of it. Even today, when Microsoft didn't get to rule the internet as they wanted, they're still the single biggest source of 0 days out there. So I think this let the models take care of security is a profoundly mistaken approach, and I think it's a big area that's yet to be really explored. Like I say, at some point there's going to be a big incident or vulnerability discovered, and people are going to sit up and start taking it more seriously.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you're doing on Pydantic AI. It's definitely a very interesting framework. I appreciate all of the effort you're putting into making the agentic development process better and smoother and easier, and including type safety. So I appreciate all of the work that you're putting into that, and I hope you enjoy the rest of your day.
Thank you so much.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.